The symmetry group of Bessey sequences of order 32. Preliminaries. 1. Recall that each Bessey sequence of order 32 is simply the concatenation of a quasi-Bessey sequence of order 16 and its inversion. 2. A permutation that preserves or inverts Bessey sequences is called a Bessey permutation, and any physical shuffle of a packet of playing cards that yields this permutation of the cards is called a Bessey shuffle. 3. For ease of nomenclature, I will use permutation and shuffle interchangeably. 4. The set of all Bessey shuffles form a group under composition. 5. This group is called the group of symmetries for Bessey sequences, or the symmetry group of Bessey sequences. 6. In what follows, we will consider the question, what is the group structure for all Bessey shuffles of order 32? In other words, what is the symmetry group for Bessey sequences of order 32? Analyses. 1. How many permutations preserve or invert Bessey sequences of order 32? Here is one such Bessey sequence, or expressed with indices, it becomes the following. Viewing the 16 ones as equivalent but distinguishable, and the 16 zeros as equivalent but distinguishable, we obtain the following total number of distinct permutations that preserve or invert the above sequence structure. This total comes out to be approximately 8.755 times 10 to the 26th power. 2. Therefore, the cardinality of the group of symmetries that either preserve or invert Bessey sequences of order 32 is approximately 8.755 times 10 to the 26th power. 3. Fortuitously, among the shuffles already presented on the Hidden Structures channel that either preserve or invert Bessey sequences of order 32, we find several minimal generating sets for all 8.755 times 10 to the 26th power elements in the symmetry group of Bessey sequences of order 32. 4. Rather surprisingly, there is one shuffle among those presented on the Hidden Structures channel that is a required member of any generating set for the symmetry group of Bessey sequences of order 32. This special shuffle is the Australian down-under shuffle, whose permutation representation is as follows, where double-digit numbers are underlined to enhance readability. 5. Here, I provide a partial list of minimal sets of shuffles that generate all approximately 8.755 times 10 to the 26th power symmetries of Bessey sequences of order 32. First, 50% cut, together with the Australian down-under shuffle, where the 50% cut has the following permutation representation. Second, a 50% coating, together with the Australian down-under shuffle, where the 50% coating has the following permutation representation. Third, the pairwise transpose, together with the Australian down-under shuffle, where the pairwise transpose has the following permutation representation. Fourth, an even or odd up jog in which the even position cards are stacked on top of the odd position cards, together with the Australian down under shuffle, where the up jog has the following permutation representation. And fifth, the Pharaoh in shuffle, together with the Australian down under shuffle, where the Pharaoh in has the following permutation representation. Another generating set that includes our familiar LR shuffles is the following. It's the LR shuffle in which the left pile is stacked on top of the right, and the LR shuffle in which the right pile is stacked on top of the left, together with the Australian down under shuffle. Please note, however, that this generating set is not minimal, nor are the generators independent, since neither LR shuffle can be removed and still generate the symmetry group of Bessey sequences of order 32. I include it here because of the ubiquity of LR shuffles, and as a reminder that any shuffle that is a consequence of the stay stack principle is a member of the symmetry group of Bessey sequences of order 32. But of course, the real workhorse for fully generating the entire group of symmetries for Bessey sequences of order 32 is the Australian down under shuffle. 6. According to GAP, a computational discrete algebra system, the group of symmetries that preserve or invert Bessey sequences of order 32 is isomorphic to the following, where the colon denotes a semi-direct product, and A sub 16 is the alternating group on 16 letters, and Z sub 4 and Z sub 2 are cyclic groups of order 4 and 2, respectively. Important observations. 1. If you LR deal into two piles a packet of cards arranged as a Bessey sequence of order 32, then each of these two dealt out piles will constitute a quasi-Bessey sequence of order 16. 2. If you deal out the top 16 cards of a packet arranged as a Bessey sequence of order 32, then the dealt out pile will constitute a quasi-Bessey sequence of order 16, and the structure of the remaining 16 cards in your hand will be its inversion. 3. If you divide in half a packet of cards arranged as a Bessey sequence of order 32 by way of an even or odd up jog, then each half will constitute a quasi-Bessey sequence of order 16. 4. Again, I wish to emphasize an important consequence of our previous analyses. Any shuffle that preserves or inverts Bessey sequences of order 32 has a representation as some combination of products of the 2 or 3 permutations listed within each of the 6 generating sets given earlier. Surprisal interpretation. 1. The total number of permutations of 32 cards is 300,540,195 times the number of Bessey shuffles of order 32. This is in stark contrast to what we found regarding Bessey shuffles of order 8. In that case, the total number of permutations of 8 cards is only 35 times the number of Bessey shuffles of order 8. 2. Informally expressed in the language of information theory, and more specifically in units of surprisal based on the above calculations, we find that a random shuffling of the cards that results in either preserving or inverting an arrangement of the cards as a Bessey sequence of order 8 generates log base 2 of 35 bits of surprisal, which is approximately 5 bits. 3. On the other hand, a random shuffling of the cards that results in either preserving or inverting an arrangement of the cards as a Bessey sequence of order 32 generates log base 2 of 300,540,195 bits of surprisal, which is approximately 28 bits. 4. For those who have watched my series on information theory and math card magic, you'll know how to interpret both of these answers in terms of ordinary coin tosses. In particular, 5 bits of surprisal is the degree of surprise one would likely experience in witnessing someone correctly predicting that 5 fair coins randomly tossed into the air would all land heads up. And they do. Whereas 28 bits of surprisal is the degree of surprise one would likely experience in witnessing someone correctly predicting that 28 fair coins randomly tossed into the air would all land heads up. And they do.